This problem, compound inequality, we solve each inequality individually, separately, and then we'll see what we do about the and. To begin with this inequality, we want to get the x term by itself, so we add 4 to both sides. And while we're at it, this inequality, we're also trying to solve for x, so we'll add 8 to both sides. Assembly line solving here. This ends up equaling 6x, greater than or equal to 2 plus 4 is 6. And this one ends up equaling 3x, because the 8's cancel out, is less than negative 2 plus 8, just 8 minus 2, which is 6. To finally solve these inequalities, all we have to do is divide this one by 6 on both sides to cancel the coefficient of x. And this side we divide both sides by 3 to cancel the x coefficient. We're then left with x is bigger than or equal to 1, and at the same time we want x to be less than 3 goes into 6 2 times. So this is our solution. X has to be bigger than or equal to 1, and at the same time x has to be smaller than 2. You could put this together directly into an inequality, three-way inequality, or we could do it by graphing first, which I recommend. So graphing this inequality, we have 3 number lines here, and we're going to graph the solution to this inequality on the first number line, this inequality on the second number line. And then at the third line we'll see where is it true that both inequalities are satisfied. So as you may recall, we're making 3 number lines that are all the numbers are lined up. The 2 numbers of importance here are 1 and 2. So let's let this be the number 1 on all 3 lines. And over here we'll call this 2 on all 3 lines. Just 3 number lines with the numbers all lined up. So on the first one we're going to graph this inequality. X is bigger than or equal to 1. So we put a circle around 1, and we include the 1 because it's or equal to here. And then there's an arrow to the right, because x is bigger than that 1, so it's to the right. So that's the graph of the solution to the first inequality. X is bigger than or equal to 1. The second inequality we'll graph on the second line, so x is smaller than 2, x is less than 2. X is to the left of 2 on the number line. So graphing this, we get an arrow going to the left. So now you can see, oh, notice that we're not including 2 here. X is strictly less than 2, where here x could equal 1, so we filled in the 1. Okay, so now that we're looking for the overlap, remember the word and is intersection in terms of sets. And the intersection, upside down U, is the overlap of the 2 sets. So where do these 2 shaded regions overlap? What numbers on the number line are in the shady parts of both lines? And you'll see that, well, over here it's only in this one but not in that one. In other words, the second inequality is satisfied but not the first one. Between here, both are satisfied here, so we're going to fill in including the number 1, because that's included as part of the solution of both, all the way up to 2. So there is the graph of the solution in interval notation. Notice over here there's only solutions in the first inequality, but those values of x are not solutions in the second. So anyway, the interval of solution is, we can see right here, graphed. In interval notation, that's the closed interval from 1 up to 2, closed on the left and open on the right. And this, in set builder notation, is a set of all real numbers x such that 1 is less than or equal to x, which is less than 2. So there it is, graphed, written in interval notation and in set builder notation. Well, there you can see the interval from 1 to 2 here, closed on the left, open on the right, everything between 1 and 2, and that's a set of all x, real numbers x, such that x is in between 1 and 2, including the 1, but not including the 2.